TypeScript has something called variable types, which allows you to reuse types in different ways. These are called type generics and they're very useful. Let's say we have this function called getRandom. Then here we get a random value from that array. You can think of any logic here for getting random value. I'm just using the index of 2 just for example's sake. Now here we have a fruits variable. This is an array of strings. Then we have the numbers variable, which has an array of numbers. Now let's say we want to get a random fruit and a random number. Fruits, TypeScript infers it to be an array of strings. We could also come here to explicitly say this, but we don't have to. TypeScript will help us figure that out. Then here, numbers is an array of numbers. But then when we get a random fruit, you can see that the random fruit has an any type. And here in random number, you see it has the any type. But we would expect that random fruit should have the string type, since it's going to be getting a random from these strings. And random number should have a number type because it's going to be getting a random from these numbers. Well, the reason why this has an any type is because this R parameter by default has an any type. You can see that it implicitly has an any type. I could also explicitly say it as any, or I could even say it as any array, which means an array of anything. Now, because this is an array of anything, it means that random is going to be any, and we return any from this function. So how do we sort of tell this function that I am going to pass an array of strings, or I am going to pass an array of numbers, or an array of objects? And this is where we can use variable types. How do you create variable types? Well, here we have the less than and greater than symbol, and then you can have your variable type. You can call this anything. You can call it type. You can call it Deeecode. If you like my channel so much, you can call it T. Actually, you'd see a lot of people call things like this T, U, or V, but let's just keep it as type. So this variable type is going to be passed to this function, and we can now use this type anywhere in the function. So we can use this type here. So instead of having any, we have type, which means an array of this type. And then we can also say that this function is going to return the type. Now, at the time of declaring this function doesn't know what type is going to be. Now here, where we're using this function getRandom, we can now pass the type that we want. So here I can pass a type of string. And now if I should hover on getRandom, you can see that it says function getRandom string. The R here is typed as array of strings, and it returns a string. And then here I can also say number, and now you can see getRandom is going to be number, an array of numbers returning number. So this is how with a variable type, a generic type, we can pass different types to this function in the different places that we use it. This is what makes generic types reusable. And now you're going to see that random fruit is a string and random number is a number. And because of type inference, we can even remove this from here. TypeScript is going to infer that this returns the type, because if we're getting a random from this array, then random is basically going to be the type. And because of TypeScript inference, again, we can also come here to remove this and remove this. That's because this fruits is an array of strings, and this function receives an array of type. So if this is an array of string, then that is basically string array like this, which means string is the type. Same thing with the numbers. Since this is an array of numbers, then the random function is going to infer that the type is number. So random fruit is a string, random number is a number. So you can see why I said earlier that type inference makes the developer experience with TypeScript really nice, because all we had to do here was just introduce this type and this type here, and we didn't have to do any other thing explicitly. TypeScript inferred the rest. You can use type generics with functions, and you can also use it with interfaces. Let's say we have this interface called storage item. This interface has a key of string, and then it has data. This data can probably be a string. It could be a number in the storage, or it could be an object in the storage. Now, instead of having this union of different types, we can make this storage item interface useful by again introducing a type generic. Let's give this T. And then for this data, we can simply pass T. So now if you're using this interface, let's say we have item. So you can have it as storage item, and then you pass string, which means this item is going to have a key of string and a data of string. Or you can say storage item number, and now we have an error here because type string is not assignable to type number, and then for this data you can have number. Or you can say storage item and you can have an object with a name of string, and then for this data we can pass name of string and everything matches. Or instead of interfaces, you can also have type aliases. So we're going to have type storage item, and then you have the equal to here, and the same thing works fine. We have this generic, and then you can use the generic here. You can even have multiple generics. For example, you can have, let's call this generic data, and then we can also have a generic for key. We can pass that key here. So which means maybe the key can be a string or it can be a number. And then here in this storage item, this is going to be for the data. And then we can have another one for this key, which is going to be string. So now that works fine. If I have number here, well, now we have an error here because string is not assignable to number. But if I pass a number here as the key, everything works fine. And you can make some of the variable types optional. For example, with this key here, if I should do key equals string, that means this is an optional generic type which has a string type. So if I don't put anything here, it means key would have to be a string because this is the default. But then if I want it to be something else like a number, then I can explicitly provide that as a number, and I can change this here to a number. Now, if you remember earlier, we used something like array, and then we passed number here like this. Let's say 1, 2, 3. Now this is a type generic too, where we have this array interface, and then we can pass the type of items in that array. We can actually create something like this too. So I can call this type my array, which takes a generic. I call this T, and then here I can just do T array like this. And now I can use my array here, and I pass number, and this works fine. If I pass string, I'm going to have an error, but if I change everything here to strings, then you can see that also works fine. In TypeScript, you're going to see generic types used a lot, especially when you want to create advanced types. So it's very important to understand this concept, and I hope that these examples shows you how type generics work, also with the help of type inferences to make your lives easy. And I hope that it also shows you how this allows you to create reusable interfaces or reusable functions that you can use in different ways.